Hi my dear students, this is Murthy. Welcome back to Raghav Math e-learning. In today's video, I am going to discuss about domain of a function. What is domain of a function and how to find domain of a function. See, coming to domain, the set of values of x where a function is defined, those values are called domain. I mean, suppose I am going to take one function f of x equal to suppose x plus 2. For what values of x this is defined, those values are called domain of the function. So where it is defined? Yes, it is defined for all real numbers, is it? Whatever real number you want, you take in place of x, then you can get some output, is it right? So this function is defined at everywhere, is it? So domain of this function, that is real number set. So here you can take any input. Here you can take any input. So domain of this function is the entire real number set, is it? Suppose the function is f of x equal to 1 by x minus 2, is it? So can I take x equal to 1, x equal to 3, x equal to 5? Can I take x equal to 2? No. Why? If you take x equal to 2, in denominator you can get 0, is it? So in denominator if you get 0, that function is not defined, is it? So this function defines for every real number except 2, is it? So what is domain of this function? That is entire real number set other than 2, is it? So domain of this function is real number set minus the set 2. Is it clear? So what is domain of a function? Domain of a function is a set of values of x where the function is defined, is it? So to find domain of functions, we have some important points. I mean, you should know where a rational function is defined, where a square root function is defined, or where logarithm function is defined. Like that, you should know some points to find domain of the functions. See, suppose a rational function f of x by g of x. If the function is a rational function, it is not defined when g of x equal to 0, is it? We know that if denominator is 0, then the rational function is not defined, is it? See here, 1 by x minus 2. It is also one rational function where it is not defined. If denominator is 0, that function is not defined, is it? So here a rational function is not defined when denominator is 0. Coming to second one, it is square root function. You know that when square root function is defined, the value in the square root must be non-negative, is it? So here f of x must be either positive or 0, is it? So this function is defined only when f of x greater than or equal to 0, is it? Suppose the function is like this, then this function is defined. See here, in denominator we have square root. So the value in square root must be positive, but here we can't take it is 0. Suppose if it is in numerator, if it is 0, it's not a problem. Root 0, that is 0 defined, is it? But if you take this is 0, then in denominator you get 0. That is the reason if function is like this, then this is defined only when f of x greater than 0. Suppose the function is log f of x. So when a log function is defined, so the input for log function must be positive, otherwise that is not defined. So here what is input of this log function? That is f of x. So log f of x is defined when f of x greater than 0. Is it? Suppose the function is log f of x to the base g of x. This is defined when the input should be positive, so f of x greater than 0, and base always positive but not equal to 1. Must remember that. So this function is defined when f of x greater than 0 and base also greater than 0, and the one more important point for this is base always positive but it never be 1. So to answer the questions related to domain, you must know these 5 points. See here, now we find domain of this function. Once you observe this function, is it a rational function? Yes, it is a rational function like f of x by g of x. So we know that when a rational function is not defined, if denominator is 0, that function is not defined. Is it? So this is not defined. This is not defined when this denominator is 0. That is x cube plus 4x square plus 3x equal to 0. So where it is 0, you find x into x square plus 4x plus 3 equal to 0. So do simplification, you get x equal to 0 or minus 1 or minus 3. Is it? You can do factorization, then you can get these values. Is it? So at these values, is this function defined? No, this function is not defined at these 3 values. Is it? So can you tell domain of the function? So entire real number set except these 3 values. So minus, set bracket, minus 3, minus 1 and 0. So this is domain of this function. Is it clear? Coming to second one. They are asking domain of square root of 9 minus x square. Is it? Listen carefully. Domain means what? We have to find the values of x where the function is defined. Is it? So here you see that in root we have 9 minus x square. When root function is defined, the value in root must be greater than or equal to 0. Is it? So now this time this is defined when 9 minus x square greater than or equal to 0. Is it? So we have to do simplification. Listen, multiply this with minus. Then we get x square minus 3 square. If you multiply one inequation with negative sign, inequation sign changes. Is it? So greater than become less than. Now this is like a square minus b square. What is it? X plus 3 into x minus 3 less than or equal to 0. You know that how to find solution to this inequation. We take real line C minus infinity to infinity and mark the points. Here x values minus 3, 3. Is it? So we take this is minus 3 and here we take 3. Okay. Now in any interval you take one point and you verify this. Okay. See, between minus 3 and 3 we have 0. Is it? You take 0. 0 plus 3 positive. 0 minus 3 negative. Positive into negative, negative. So here it is negative. Alternatively you change the sign. That's all. So plus and plus. Okay. What we want? We want less than or equal to 0. Means we want negative. Is it? So here x belongs to. So where it is negative you observe. Between minus 3 and 3 it is negative. Is it? So now the doubt is minus 3 3 included or not? See here we have equal to sign. So you should take minus 3 and 3 also. Is it? So the correct answer to this question is closed interval minus 3, 3. So domain of this function is closed interval minus 3, 3. See, coming to third one, we have to find domain of the function 1 by square root of x square minus 16. Is it? So with the numerator, we don't have any problem. But coming to denominator, x square minus 16 is under root. Is it? So when root is defined, it must be either positive or 0. But if it is 0, in denominator you can get 0. Is it? That is the reason. For this we take, this is defined. This is defined when x square minus 16 only greater than 0. Earlier I have taken greater than or equal to 0. But this time I have taken only greater than 0. Why? This is in denominator. If I take that is 0 equal to 0, then in denominator you get 0. Is it? So I have taken this. Now you have to do simplification. Can I take it as x plus 4 into x minus 4 greater than 0? Yes. Now to solve this inequation, you take the real line. So minus infinity to infinity. What about x values? Minus 4, 4. So you take them on real line, minus 4 and 4. Now how many intervals we got? 3 intervals we got. Now you have to mark where this is positive, where this is negative. I mean, in which interval it is positive, in which interval it is negative. So from any interval, you take one point and you put that point in this, and then you can decide the signs. Is it? So between minus 4 and 4, we have 0. Take 0. 0 plus 4, positive. 0 minus 4, negative. Positive into negative, negative. So here negative. Change the sign alternatively, or otherwise you want, you can verify. Between 4 to infinity we have 5. Is it? Put 5. 5 plus 4, positive. 5 minus 4, positive. Positive into positive. See? Positive. Like that here also you can take one value and you can verify. Same you can get. That is the reason I am telling you alternatively change the sign. Is it? Okay. What we want? We want greater than 0. Is it? So greater than 0 means positive. Where it is positive? Minus infinity to minus 4, 4 to infinity. Is it? So domain of this function, that is minus infinity. For infinity, minus infinity, always open interval. But what about this minus 4, 4 once you observe? Here, there is no equal to sign. Is it right? So 4 and minus 4 are not included. Is it? So it is minus infinity minus 4 union 4 comma infinity. This is domain of this function. Clear? Coming to this. Observe this function. With numerator, do you have any problem? No. Why? Because it is simply a polynomial x plus 1. Yes, this is defined at everywhere. But with what we have the problem? That is denominator and square root. Is it? So in square root, what function we have? That must be greater than or equal to 0. Is it? But can we take equal to 0 in this case? No. Why? Because that square root is in denominator. That is the reason. This is defined. This is defined when x square minus 5x plus 6 greater than 0. We can't take equal to 0. Why? Because this is in denominator. Is it? Now you have to do the simplification. So can I write it as x minus 1 into x minus 5 greater than 0? Yes. Now to solve this inequation, we take the real line. So here it is minus infinity and infinity. What values we got? 1 and 5. Again, how many intervals we got? 3 intervals we got. So where it is positive, where it is negative, you have to identify. You observe the first interval. In this interval, is 0 there? Yes. Between negative and positive, no doubt at all, we have 0. Put 0 in this. 0 minus 1 negative, 0 minus 5 negative, negative into negative positive, so it is positive. Change the sign alternatively, so here positive, so negative, here negative, so next what? Positive. What we want? We want greater than 0. Greater than 0 means, is it positive? Yeah. So domain of this function, that is positive only we want. So what? For infinity minus infinity, always open interval. And here only greater than we have, there is no equal to sign. So 1, 5 not included. So what? Minus infinity comma 1 union 5 comma infinity. So domain of this function is minus infinity comma 1 union 5 to infinity. Moving to next, we have to find domain of the function log 18x minus x square minus 77 to the base 3. Is it? See here, domain means what? The set of values of x where this function is defined. Is it? So it is a log function. Where log function is defined, I mean in log what input is there, that must be positive, otherwise that is not defined. Is it? So we can write that this is defined when 18x minus x square minus 77 greater than 0. Is it? So to do simplification, first you multiply with minus sign. So if you multiply with negative sign, inequation sign changes. Is it? So what we get? That is x square minus 18x plus 77, this greater than become less than 0. Is it? Now do the simplification. So factorization. Then you can get, so minus 11x minus 7x plus 77 less than 0. Is it? So can I take it as x minus 11 into x minus 7 is less than 0? Yes. Now to solve this inequation, we have to use the real line. Is it? So you take real line and you mark the points 7, 11, infinity, minus infinity. Again we have 3 intervals. Is it? So you have to decide the signs. Is it? Now between minus infinity to 7, is 0 there? Yes, you put 0. Then 0 minus 11 negative, 0 minus 7 negative, negative into negative positive. Change the signs alternatively, negative, positive. Okay. Now what we want? We want less than 0. So less than 0 means what? Negative. Where it is negative? Between 7 and 11. So answer to this problem is x belongs to 7 comma 11. Now our doubt is 7 11 included or not? Here only less than we have, there is no equal to sign. So answer to this problem is x belongs to open interval 7 comma 11. Clear? Coming to this, 1 by log mod x. So we know that log is defined only for positive values. Is it? Here what we have? Mod x. So even you take negatives, here you can get positive only. So not a problem. Is it? But this is in denominator. Is it? This is in denominator. So it must not be 0. Is it? So you can tell. So first log function na? So this is defined. This is defined when this must be positive. So mod x is greater than 0. Is it? And suppose mod x is 1, then log 1 become what? 0. Is it? Why? Because it is in denominator. Is it? So if it is 0, that is not defined. When log function is 0, log 1 is 0. Is it? So this is defined when mod x greater than 0 and mod x not equal to 1. is it? You tell now. When mod x is positive, x belongs to all real numbers except 0, is it? If I take 0, then that is 0. But here we have mod x greater than 0, is it? And mod x not equal to 1 means remove modulus, you get plus or minus. So what we got? X is any non-zero real number and x not equal to minus 1, 1, is it? So can you give the domain of the function? You can take entire real number set except minus 1, 0 and 1. So this is domain of this function. Coming to seventh one, f of x equal to square root of x minus 3 by x plus 3. We have to find domain of this function. Okay, you observe this function. This function is in square root, is it? So you tell when this is defined. So this is defined when x minus 3 by x plus 3 greater than or equal to 0, is it? And is x plus 3 in denominator? Yes. So if x plus 3 is 0, is this function defined? No. Try to understand. Here we have square root function and rational function. Here we have square root function and rational function. So when square root function defined, the value in square root must be greater than or equal to 0. So this must be greater than or equal to 0. And when rational function is not defined, denominator is 0. So when it is defined, denominator is not equal to 0, is it? So and x plus 3 must be not equal to 0. Is it clear? Right. Now we simplify that. Listen carefully. Here we have x minus 3 by x plus 3 greater than or equal to 0. Is it? See, to simplify this, some students, they do cross multiplications. That is wrong. In any equation, without knowing sign of the denominator, we can't go for cross multiplication. Why? Because if it is positive, it's not a problem. But if it is negative, you should change inequation sign. That is the reason. If you are not aware of sign of denominator, blindly you don't do cross multiplications. So what we have to do, that is, it is like a by b greater than or equal to 0. If it is a by b greater than or equal to 0, just you write it as a into b greater than or equal to 0 and b not equal to 0. Is it? Why? Because if b 0, it is not defined, right? Okay. So it is like a by b greater than or equal to 0. So we can't go for cross multiplication. So I can apply that concept, that is x minus 3 into x plus 3 greater than or equal to 0 and x not equal to minus 3. Is it clear? Right. Now we have to do simplification. So what? That is real line I have taken. It is minus infinity and this is infinity. So here we got that minus 3 and 3, is it? Now here we got 3 intervals, is it? So now you have to discuss the sign, right? So between minus 3 and 3, we have 0, put 0. 0 minus 3, negative. 0 plus 3, positive. Negative into positive, it is negative. Change the sign alternatively, plus plus. So here what we want? We want positive, is it? So you tell that what? That is x belongs to where it is positive. So here positive and in this positive. So answer to this problem minus infinity to equal to also there. So minus closed minus 3 union closed 3 to infinity. Is it? But and what we have? X not equal to what? Minus 3. Is it? So we should not take minus 3. So can you give the final answer? X belongs to minus infinity, open interval minus 3, union closed 3 to infinity. So this is domain of this function. Is it clear? Right. Coming to this problem. Observe this. With 10 power x, 10 power minus x, we don't have any problems. Those are defined at everywhere. Here we have denominator. So if denominator is 0, that is not defined, is it? So this is not defined. This is not defined when denominator is 0. That is 10 power x minus 10 power minus x equal to 0. That is, we have 10 power x equal to 10 power minus x. So x equal to minus x. 2x equal to 0. So what is x? X equal to 0. So at x equal to 0, is it defined or not defined? Not defined. Can you tell what is its domain? Entire real number set except 0. This is the answer to this problem. Moving to next. F of x equal to root 2 plus x plus root 2 minus x whole by x. Okay? Listen carefully. Here we have root function. So when it is defined, so this is defined when 2 plus x greater than or equal to 0, is it? Here also we have a root function. So and 2 minus x greater than or equal to 0, is it? And totally here one denominator we have, is it? So denominator must be not equal to 0, is it? So and x not equal to 0. I think you understand. Here it is root function. So when it is defined, the value in root must be greater than or equal to 0. So 2 plus x greater than or equal to 0. And here 2 minus x greater than or equal to 0. And x not equal to 0. Clear? Right. Now we do the simplification. Here you see, is it x greater than or equal to minus 2? Yes. And here you see that multiply with minus, then what you can get? X minus 2 greater than become less than. Why? Because we multiplied with minus. And x not equal to 0, is it? So we got x greater than or equal to minus 2 and x less than or equal to 2 and x not equal to 0, is it? Right. Now this function is defined for these values of x. You have to give the final answer, is it? So here between we have and, is it? So we have to find that common part, is it? So you tell now, x greater than or equal to minus 2. See, minus 2 and 2. X greater than or equal to minus 2, but less than or equal to 2. Did you understand? So the common part is between what and what? Minus 2 to 2, is it? But between minus 2 and 2, we have 0. But here, what we got? X not equal to 0. Did you understand? So the domain of this function, that is equal to, so closed interval minus 2 to 2. But from this, we have to remove that 0, is it? So minus 0. This is the answer to this problem. Or we can represent this as closed minus 2 open 0. 0 is not included. Union 0 to closed 2 means we have taken all the values from minus 2 to 2 except 0. So one can give answer like this. Clear? Coming to this problem. Here it is square root function. When it is defined, so here this is defined. This is defined when mod x minus x greater than or equal to 0. Is it? Why? Because in root function what we have, that must be greater than or equal to 0. Is it? So what? It is mod x greater than or equal to x. We know that mod x always greater than or equal to x. Whatever real number you want, you take, whether it is positive number or negative number, always it satisfies, is it? Why? Because mod x always gives that absolute value. So even if it is negative, no doubt at all mod x must be greater than x. Suppose if it is positive, mod x is equal to x only. So this is true for all x belongs to real numbers. Is it? So what is domain of this function? That is real number set. My dear students, hope you understood this concept. Share this video with your friends, subscribe to my channel, click the bell icon to get latest notifications. Thank you.